Hello and welcome to the webinar Aircraft Interior Lighting Validation. My name is Irina Kollinger. I'm application engineer at Ansys based in Germany, and I'm in the lighting and visualization team. And we'll present you today's webinar on the topic focusing on virtual validation for aircraft interior lighting. For the agenda, at first, I will start with an introduction and overview about Ansys Speos and show the optical simulation workflow. And after that, we will go through different topics where Ansys Speos tools can be used for virtual validation, in the interior lighting. So such as virtual lighting animation, possibility of simulating different sun positions, texture mapping preview, RGB development, optical analysis and standards validation, human vision, glare analysis, 3D irradiance sensor, and legibility and visibility analysis. Okay. Optical applications in aerospace and defense. So we assist our partners in many aspects of the design and engineering process, including safety, ergonomics, and perceived quality. And this translates in several topics, such as human-machine interface development, validation of exterior lighting, hood color and material choice, and of course, interior lighting, on which we will focus today. So basically, optics enables innovation for our partners anywhere, lighting, human vision, and sensor vision are involved. And today we will focus on the interior lighting. Okay, here you can see an overview of the product portfolio of Ansys products and where Ansys Speos is integrated in. So Ansys Speos allows optical system optimization and validation within a multi-physics platform. So it's a standalone 3D optical simulation flagship. So the Ansys Speos platform includes the SpaceClaim CAD software. And it's compatible with all CAD platforms. So it's easy to use. You can import CAD data from CATIA, NX, and any others. And you have physics-based modeling that with simulation of all materials and sources that enables you for reliable decision making. You have a powerful, easy to use analysis tools and also the possibility of a secured data exchange through our Speos Lightbox. And with an accurate engine and algorithms, you get precise true to life results in a fast time. And it's HPC and GPU ready. So we have also GPU-based simulation to shorten design iteration cycles. And the Speos provides strictly true to life rendering, as I mentioned before. And their correct optical properties of materials and light sources are combined with physical ray tracing of light, and so can ensure a 100% true to life representation. And for this, we have an optical library that is based on optical properties and light sources and several standards. and this is free accessible to our customers through the customer portal. Okay, so here on this slide you can, there's an overview of the optical simulation workflow. So on the left side you have the inputs and on the right side the outputs. So at first it's very important to have good and proper inputs that are applied on the cut geometries that are imported or generated in Ansys Speos. And as I mentioned before, for this we provide our free online library. And you can use them, or you can also use specific material measurements or create from datasheet customized materials. So once you have defined the optical properties in a good way, create the light sources. So it can be visible light, infrared, or ultraviolet range. LEDs, surface sources, can import ray files, IES, and also define with HDRR files an environment source, ambient sources. So and then we need to define optical sensors. So position the sensors to measure. So we have different type of sensors depending of which analysis you want to do. For the optical sensor, you can go from photometric to radiometric and spectral condition. And so every input will be set and positioned and defined on a cut geometry. And this cut geometry will have impact on all the information. And then we can run a simulation through these elements to be able to recuperate results from the sensor position to see and analyze what's going on. So you have then a sort of snapshot of what's going on at a certain amount of time with the condition you have defined. And then finally you have the results to analyze and check regressions and validate it. So this is the general workflow. And here you can see the graphical user interface of Ansys Speos. For those who haven't seen it before. And there you can also see the three main blocks I mentioned before. So we have our geometry with the optical properties. We set our sources, our sensors, and have our simulations and check the results. And as mentioned here, it's a simulation software shooting rays that interact with geometry and are detected by a sensor. But not only this, it also generates optical geometry. So you can go from component design to cabin integration. You have, as I mentioned, you have with Ansys Speos also the opportunity to generate optical geometry, as you see here at the bottom. And with optical part design, there you have the different possibilities to create reflectors, optical surface lenses, light guides. So you can design components and integrate them into a whole cabin to validate the lighting design. And here I want also to mention our Speos Lightbox. So it's a black box format for data exchange. And with this, you can easily communicate between supplier and integrator and protect IP. So, and now we will continue with the virtual validation for aircraft interior lighting. In this example for an aircraft passenger cabin. But at first, what is virtual validation? So virtual validation is the process engineers and designers follow using computer-aided engineering to implement a digital version of a product. So its validity can be tested and proved virtually. So the advantage is digital prototyping reduces development and validation time as well as costs. And in the next slides, I will show some examples how Speos can be used for such virtual validation. So here at first, I will show a result, a video animated that here you can see an aircraft passenger cabin and different lighting conditions, changing the color of roof lighting at the top and at the sides, as well as turning on and off reading lamps. So this video was made by post-processing simulation results. And such post-processing on Speos simulation results can be easily done with the virtual lighting animation tool. So there you can define timelines for each source's power ratio and directly produce animation videos out of them. So it's a good tool. So you have to open a result, and under tools, you will find virtual lighting animation. This will open another window, and there you have to import the result and define, and there you can then, you will see all your sources you have in and can define for each source a timeline, so the power, and then produce a video. And this definition is also possible with an Excel sheet that can be imported, or you can export your file from here. And there you can also consider the human vision response for the video animation. So you have here a nice possibility to show different lighting scenarios. And yeah. Okay. With Ansys Speos, you have also the possibility of different sun positions that you can simulate. So therefore, Speos provides several ambient sources, which you can see here, just uniform or different CAE standards, natural light, and also you can load an HDRI, for example, to have an environment when you're looking out of the window. And in this example, I used the natural light, and there you can set different properties such as direction, turbidity, time zone, and locations. You can set up several types of it and simulate it in one simulation. And after that, you can check, how it's looking like, the shadows with on the several sources. So therefore, we have the virtual lighting controller. And so you can then, and the post-processing, turn on and off the several light sources and adjust also the power. And there you have also possibility that you can combine such results with interior lighting results, and yeah, can validate different scenarios if you want. Yeah, the texture mapping preview. So material realism can be improved by applying textures in addition to optical properties for visualization use cases. For instance, fabrics, leather, or brushed metal will never look so realistic without a corresponding texture. And with the texture mapping preview, you provide a way to directly display the textures on the geometries in the 3D view of Speos. And as you can see on the video, the automatic update provides an easy way to adjust the size, orientation of the texture with the direct impact in real time. Yes, and here's also, you have also the possibility of a simulation preview to check directly how it will look in the simulation afterwards. So the result is displayed in a dedicated window and calculated with GPU in real time. So it's to check before starting a long simulation, and it also can be stopped and several things changed and then check again. Okay, now to the RGB development for ambient lighting. We have a colorimetric result here with 3 sources, red, green, and blue for the top lighting. And we want to achieve a specific color or colorimetric standard. So for this, with simulated with colorimetry, for each pixel or measurement area, you can display the chromaticity coordinates. So with this colorimetric data that you can see here, and check the conformity with regulations and colorimetric standards. So with right click here, you can hide and unhide several standards. So here I have just selected one example, but there are also others that you can use. And we see to be in this box here for the yellow, but I'm not inside. And then also using the virtual lighting controller, we can adjust for red, green, and blue. We can adjust the different power or ratio and change the color mixing, and finally get a nice result and reach our dedicated target or specification. Okay. So, and also optical analysis. So here we have a result opened in the virtual photometric lab, and it enables you to visualize spectral luminance maps. And then you can open the measures tab and can set up different type of areas, define size, or enter the type of magnitude to measure then see the flux or average or anything else. You can set also thresholds or create rules to define safety margins, or you can just load specifications that are also available in our library. And then you can analyze to ensure compliance with these regulations and requirements. So on the right side, you see, for example, for the exit sign and for the LED passenger reading light specifications, and they can be easily loaded in your result afterwards, and then check if check your regulations. So here in the luminance map, you can see then you have the different points, and on the right side, you can check if it's failed or passed. So red is failed and green is passed. Okay, and the human vision physics-based renderings and Speos. We all know typical screen limitations like resolution, contrast ratio, brightness, size, and high dynamic range. So here above, you can see the human eye sensitivity has a great dynamic. The dynamic of the standard screens, like here LCD or HDR10, are not able to display this scale of the human eye. So for this purpose, Speos human vision simulation feature is to overcome this classical display limitations in terms of luminance dynamic range. So the human vision smartly adapts the displayed luminance and contrast, emulating physiological properties of the human eye, like the glare, depth of field, acuity, and temporal adaptation. So there you can set up different parameters as the adaptation type, local or dynamic. So with the dynamic, you can model the spatial adaptation of the human eye, or with local adaptation, the accommodation is on a fixed point of the luminance map. You can set the observation time, age of observer, color deficiencies, and glare effect. Okay, also important to check the discomfort glare in interior lighting. And the unified glare rating value, UGR, is based on the CIE 117-1995 standard. And the principle is to add up all light sources luminance and compare this value over the general background luminance. So an observer's eye will be more easily dazzled by a light if the background luminance is low. Now, in this example, you see it here, it's from a passenger seat point of view. And for calculating the UGR value, you have to set a threshold, so candela per square meter for the source detection, and then the UGR value is automatically calculated by the formula and shown in the measures. So UGR values generally range from 10 to 30, and in this case with nearly 12, the glare is in an acceptable range. One other useful thing is the 3D irradiance sensor. It allows you to analyze the light contributions for each phase of a geometry. So each selected face becomes a sensor and computes irradiance or illuminance. And yeah, to set it, you can set it everywhere on the floor, on seats, table, and analyze the light contributions there. And yeah, also with the virtual lighting controller, you can then switch on and off different sources, change the power, and yeah, check it. And the result you can also rotate and zoom in. And even if it's not directly a topic for interior passenger cabin lighting, more for cockpit, I want to mention the legibility and visibility analysis tool. It's to analyze and ensure visibility and legibility of characters on a display, considering glare effects and time detection. And now we are at the end. So we have seen many benefits Ansys Speos can bring through virtual validation that lead to gain in time as well as cost and to final product reliability. Ansys Speos enables predictive optical simulation for informed decision making by using accurate inputs from optical library based on optical properties, textures, light sources, standards. Yeah, with a physically accurate ray tracing engine and perform light output analysis as we saw photometry, colorimetry, glare, RGB, UGR, and yeah, regulation compliance. And as well, we have realistic human vision rendering in different scenarios